once you've kind of started to scan in, right, and once you actually like have fulfilled that interface, we don't care, right? That's the whole point. So system.in is the same thing as SDN. Okay, let's run something as simple as enter some numbers separated by spaces. Sure, that's fine. And we'll put it all on the same line just for aesthetics. And then we'll create a sum, right? So what we're going to do is we're basically just going to read all the lines in, we're going to sum them up, and that's it. Now, this is not particularly good code, but that's okay, right? And we could benchmark this if we really wanted to. I am not going to, but feel free if you want to. And we could compare all the methods. Okay. So as simple as this should be so far, except for this, which I'll come back to, but this should be pretty straightforward, right? Now this part here is just like a TUI, right? The only difference is that it's pass int rather than a TUI, right? To convert a string to an integer. I guess the only other difference is that we call it string rather than char star. There's no real pointers. There are no pointers in Java. In kind of simulator, there's ways to simulate them, and I think there's probably an unsafe pointer class somewhere. There definitely is in C#, but in reality, you guys won't be using any pointers. But this thing here is basically just reading a line of input. This is kind of like fgets, if we want to have a similarity. And it's just going to split it. If most of you have done Python, so the split function probably makes sense, right? You're just saying, hey, split every space, and that will give you an array of every number that is separated by a space. Okay. And we could print it out. I'm just going to say sum is equal to. This is another part. Why would we give it 2 arguments? Oh, because you're running whether or not we have to give it the argument to split. So this is kind of a slight difference, is that Java doesn't really like what's called like global functions. You have in Python how you got things like map and so on. They're like global. In Java, instead, what happens is we put those functions inside classes. And the reason why is because you can't just have random functions. Oh, I'm sure there is probably an argument. Maybe. I've never heard of it. But yeah, there's a limit. Look at that. There's a limit here. You could add a limit if you wanted to. And technically this is a reject. So if we wanted to, we could give it even better, right? We could go crazy and go, here's your rejects. Is it a string rejects? Yes. And we could -s just basically means any space. In this case, it's fine to just do this. But you could use -s if you wanted to allow it to be over multiple lines, for example. I mean, you'd have to like read all the lines to input. Obviously, this comes kind of from Python as well. The only difference really is that you don't have to convert this to a string. Like in Python, you'd probably write something like this, sum them up. In this, you don't. It can just realize, hey, I have to convert this into a string. And we can close it. Now, this is technically not that important to close. It should reclaim it at the end of our program, but it's okay. So we could run this function. I'll probably run them at the end. Not really that important at the beginning. Oh, we could do it at the beginning. Why not? We'll run it once. You can press this little run button once you've installed Java. It'd probably be a decent idea if you're kind of sitting here going, hey, yeah, this stuff makes sense, to look at installing, right? To look at installing Java in Code Runner, because it can be a little bit annoying to set up. And you can find that on the site. I'll post a link to the site just for the sake of clarity now. Okay, so there you go. You can see it works here, and it works quite nicely. Yeah, so you can have a look at that. You can set up Java if you want, and it would save you a bit of time doing the actual lab section. Now, I know this is late, so if you want to leave like 6:30 or 6 at the lab, that's okay, and like go have dinner. I don't really mind. we will be marking your labs either in the current lab or in the next lab. So make sure you get it marked properly before you go. I mean, you could try to come back, but like, if you come back with like 10 minutes to spare, we'll still do it, but it's like less fair, right? Because obviously if there's a lot of people to do it. All right, so there's a few ways we can do it. We're going to begin by looking at basically writing this in a much simpler way. So this is something that you wouldn't have even seen in lectures yet. So, but I still think it's really important and awesome because it's kind of the new way to write Java. And from previous tutors, people love this because they try to like replace all their code with these methods. It looks really nice, looks clean, and it's also just a lot easy to write. Yeah, you got any question? Or is it just someone join us? Anthony, did you have a question? If you want to ask a question and are scared because I'm talking, and I'm going to set myself down, I'm just excited for some reason. You can press the little button at the bottom that says raise hand, and I'll shut up. And you can spam me if you want me to be quiet. Okay, so let's look at this newer way. So functionally, there's a few things we can do. The first thing we can do is we can look at this scanner here, and we can realize that there's this new pattern that's amazing. And we'll try resources, right? And again, it's exposure, right? So you can come back to it later. You can have a look at this when you kind of understand this stuff more, right? But like a big part of this is trying to kind of get you to understand that, especially with future languages and so on, it's really important to be able to like learn the newer parts of the language where you're still trying to grasp the simpler parts, because you don't often have a lot of time to learn new languages when you're in the kind of when you're like actually working in a job. So it's good to get some practice here and try to just like encompass everything and just use little bits and so on. And I'll try to do that as much as I can. So effectively what this is doing is it's saying try to open this scanner here. And if anything goes wrong inside of this, or I guess also inside of this, right, then what's going to happen is it's going to close it. And that's like a really cool part, right? And functionally, it's just doing this. I say functionally way too much. It's just going to do this followed by a finally. And if you've done Python, you may know a little bit about finally and try. Try catch is basically just saying try to do this bit of code, and if it goes wrong, I can catch the error and do something with it. Finally is saying, hey, regardless what happens, if there's an error, if there is an error, I always want to run this code. Technically, this would be outside the try. And you can do this pattern as much as you want, right? But the simpler way to write it is to do what I did before, right? Where you just kind of write try and you put this inside like kind of a while kind of loop. That makes sense, that kind of like weird structure. A conditional kind of placement. Anyway, so we can repeat our print line. That's fine. Nothing going wrong there. But now what we want to do is we want to basically add up a bunch of integers, right? And so we can use effectively what's kind of like a Python map and Python filter, right? So the first thing we're going to do is we're going to grab a stream. So what a stream is, and we're saying, hey, we want to grab an array stream, because as you can probably guess, this is an array, right? And the stream is basically just like it's kind of like a pipe full of water, right? And all that water goes along. There's a bunch of particulates in that water, such as like, I don't know, it could be like sewage water, so you can have a guess, right? Or it could just be like, I don't know, random fluoride or whatever, as this water is kind of going down this pipe. And we want to be able to do things to that water, such as like add things to it, maybe freeze it, maybe like filter out the bad stuff. And that's effectively all this is doing, is it's operating on every little bit of every molecule of water independently to the others. And that's kind of the big point of streams. That's what we want here, right? Now, obviously, at the very end, we want to sum them all together, but the idea is that we're operating on them individually up to that point. So the first thing that we're going to do is we're going to map them to integers. Now, I'm sure a lot of you are going, how the hell do you know these functions? How the hell do you find these functions? And the answer is IntelliSense, right? So if I just press dot here and I've got everything set up, right? I've got all the plugins installed, I will see all the functions I can perform here. You could also Google it, right? And I guess the functions are pretty obvious, somewhat what they do, like max and min, for example. Things such as skip, skip a certain amount of elements, take, create a new iterator just containing those elements. So here we have a bunch of things, and we can map this to an integer. And what we're going to do is basically going to give it a function that maps it to an integer. And our function is going to be this. Is it double? And so what this basically is doing is we're using the same function that we used here. I do not know why you have to do this. It's because this function is a static function. Basically, it doesn't work like this. It gives you a weird error. You can use this, right? Functionally, if this is a type, you should use this. If it isn't a type, if it's like a class, you can use the dot. But you don't really have to care about that. It's kind of like the pointer in C, where if one of them doesn't work, you just swap it to the other, and the other one should work. So what this will do is this will grab every value and map it to an integer. So now they're all integers. And then the next thing we're going to do is we're going to reduce it. Basically, what it's going to do is it's going to sum them all up together, right? And there may actually be a sum function. There is, but a sum function is boring. Okay, we can use the sum function. Okay, so we'll sum them all up together, and there's our sum, right? So what used to be this kind of pretty short line is now also a pretty short line. So it doesn't really seem that beneficial here, right? But this is kind of the whole point, is that I could do so much more to this, and you'll see so much more. Yeah, the sum function is boring. The other way to do it is do a reduce function. You do like a 0 and give it a reduction function. In hindsight, this function is a bit complicated, but effectively what you're doing is just saying, hey, I want to start at 0 and I'm going to reduce it so that I grab my previous value, the 0, and the current value, b, and I want to resolve that in a plus b. And effectively it turns something like this to, I mean, this is a left fold. I don't really know what way it would fold. I bet you if I scrolled over it, it'd tell me whether or not it's left or right. Yeah, also you can just use integer sum, but like, sure. Anyway, doesn't even matter. Does it say? No, not really. Yeah, so this is really the other way you should write it. You could say, hey, I want to sum up all my integers, and that would add them together. I think it's also an integer add. That would do the same thing. Doesn't even matter. But I think the dot sum is just simpler, so we'll just keep that. I don't know everything about it. I know very little in terms of the number of functions. In Java, the standard library is like probably 100 to like 1,000 times larger than C at like a rough estimate. So it's very, very large. So there's definitely things in there that you will not remember, that I will not remember. So keep that in mind. If you find there's an easy way of doing this, there probably is, right? It doesn't overly matter that much. There's our new way. It looks nicer. It's cleaner, right? There's nothing too much about it. Which way is faster? I'll have a think and get back to you in like a few minutes. The reason why is because functionally they should be almost identical, but I gotta think about how the JIT is going to affect this. The JIT loves loops like this, but it may convert this just to a loop. Like if we look at the code for map to int, fun, there's no code. But if you look at the code for map to int, all it's effectively is going to do is do as little work as possible. So like basically these are what we call lazy, which means it doesn't actually do anything until you require that element. So it's instead of like calculating an array that consists purely of integers, it just says, hey, I have my original array and I have a function that I'm going to perform for every element. And then when you want an element, I'm going to grab an element, perform that function, then give it to you, right? I also don't know if it could be simmed here. Anyway, it doesn't really matter. I have a feeling that this would be faster, but the difference would be less than 10%. In practice, it'd be very, very small. And we'll come back to the C code. it doesn't really matter. In reality, it could even be faster for more complicated examples because you can do things that are typically a lot more complicated in terms of like how you're going to express them. You can do them simpler, right? And so simpler code typically is faster. But in reality here, the cost is most likely the split function, not the sum function. Splitting requires you to go through the entire list and constantly resize the array to fit it, which is reasonably expensive. Okay, so we're just going to write a very simple shadow function that just shouts at us. It's going to scream. So to begin, we're just going to give it, I don't know, a message. Doesn't really matter. And then we're going to create a constructor. Now, a constructor is just a way to create an object. That's all it is. It's basically just saying, hey, when I create an object, I can create it this way. And it'd be message equals message. I hate writing names that long. Okay. Probably incorrectly. So for example, I can uncomment this line here. And what I'm doing here is creating a new shader, and I'm giving it an argument shader, and it's called this function. And we'll see what that actually does in a second, right? But for the sake of this in your head, every time you say new, you can think I'm creating a pointer, I'm doing a malloc. That's how you can kind of think about it, right? Because what effectively it's going to do is it's going to do an allocation followed by calling this, which is why you can use the this keyword in this function, right? Because it's already been allocated. It's already in existence. Okay, let's keep going. So next we want to do is we want to create a function to get the message, right? So getters and setters are pretty common in Java. Often we want to avoid them as much as possible because they typically can result in bad design. But in this case, it's reasonably fine. And the reasoning why is that if all you have is getter and setter, then you're not really hiding this. I'm not like abstracting this away properly, right? I'm just basically being data, right? And that's kind of not really the point of OP. The point of OP is to abstract stuff. But in some cases like this, it's slightly more useful. And then we can, for example, have a whisper function, which is just going to, I don't know, print it out lowercase will be fine. Now, one thing I do want to talk about is the use of this here and the use of not requiring this here, right? So this is a very special kind of member. It basically talks about the current class. And so effectively you require it because Java's pretty smart and will add it for you. But we can have conflicts. For example, here we have two messages and these things are named the same, right? So what you may be thinking, you may be going, well, when I do message equals message, isn't it just going to grab this and set it to itself? And the answer is yes, it will, right? As it says here. And so what we need to do is we need to tell the compiler which one's which. And when we say this dot message, we're saying, hey, we're talking about the class's message. We're talking about the member variable. Otherwise, you're always talking about this variable here. If this variable here does not exist, like for example, in this case here, right, we don't need it. It's only when this exists that you'll see this. A lot of people like me kind of get lazy and just end up writing in a lot of places because it really doesn't matter. Like even stylistically, it does not matter, but you can be a bit of a, I don't know, crazy about it and kind of care a bit more if you really want. Yeah, so we can talk about the design of this in later classes, but this is not a great design for an OP class, but it is a Java class example, right? And it's pretty straightforward, right? So we could run this and we would get a shout, a whisper, then followed by two yays. That's my code. I don't know why it does this, but my terminal like slowly types things out in this terminal. It's like trying to be, I don't know, whatever, extra. It shouts, then it whispers, then it shouts, then it whispers. We can see it here. Okay, wonderful. And we're using the two lowercase and two uppercase functions here, right? And again, if you go, oh, how do I convert a string to uppercase? Magical thing called Google, right? Oh, we have to add Java. Okay, and click on the first article and it'll probably tell you, right? So Google's really, really good for most programming languages. C is one of the ones where it can be a bit because C is pretty hard and has a bunch of different opinions. But for things like Java, it's it's probably always going to be right. So we're just going to begin and finish this off. We are going to be a bit late. Did the lab assistant join yet? So I don't remember who it was. Let me look at my computer so when they join,
It
I
is
can tell.
I.
Oh, Ethan. Yes, you
Hello.
did. I'll make you a moderator.
Cool.
Awesome.
I have power.
You have all the power. I'll just finish off this bit and then we can go into it.
Yep.
Thank you. So we have a starter program in C, and we're going to build basically a V table. And so the rough way we're going to do this is just start off by creating a struct starter. Right. Give it a name. And then I'm just going to give it a message. Right. Now, obviously, I can't hide this message. So this is kind of like a problem, right, with C. So how do I hide this message here, right? How do I hide this member? And there's various ways you could do it. You would have seen in previous classes things what we call opaque pointers, right? So for example, you'd have like a C shadow.h, where you could define, type def struct shadow t pointer is a shadow, right? Something like this. And that would basically say, hey, I don't know what struct is, right? I don't know what a struct is, so I can't like access it in any real meaningful way. But I kind of have this like nice wrapper on top. And I could define operations inside of here, such as like void, shout, and so on. Let me operate on my object. In this case, we're not going to do it that way just because I don't really care about hiding the character message so much. I more care about like the functions and how they work. So we're just going to write a very simple initialization function. The first thing you should notice about this is that this is actually a, let's call it this. Is that this returns void, i.e. it returns nothing, because again, just like our constructor class, it doesn't return anything because all it's responsible for is setting up the object, right? The object is already initialized by the new. The new can kind of be thought of as like a function that creates the object and then asks you to initialize it and then returns the result. Right, and we'll kind of see what that means in a second. So if we have a shout-out, right, and we can call this like new, for example, what it's effectively going to do, and this is a bad example, but this is fine, I guess, is it would just say like shout-out is malloc as of shout-out, and then we can say init this, and that's effectively what our new is doing, right? Obviously, there's a lot more repetition, right? But functionally, it's the same. I'm just going to grab this code and put it inside our main function because it's too much for my liking. Okay, and our message can just be hello world. Doesn't matter. Okay, so this is our initialization function. Now we want to create a bunch of like functions that could operate on it, right? And a very simple way would be to have like a void whisper function here. Right? And we can still do this, and we can go like for each character in our message. Right? Aha, funny joke. We can each character, right? So again, this should be reasonable. See if you've done it before. Most of you would have done it pretty recently. If you haven't, don't worry too much about it. Effectively, we're just placing each character onto the output stream after converting it to the lower version, right? This is a fine way of doing things, right? And we could write this in our normal way of doing things and say, hey, the shadow should whisper, right? But Java basically goes, well, that's okay. But like, it kind of sucks because basically what that means is that my shouter object, right? I kind of I can't generalize what functions I want to call on it. And so this is where we get things like polymorphism and inheritance in future classes, as we'll see very, very soon. But for now, we're just kind of show it in a flattened format, right? So effectively, what it's going to do is it's going to go, okay, I want to create a V table. And that's just stands for a virtual table, right? It basically just contains a bunch of function pointers. Right? And so in this case, we could contain a function pointer, which is a void function. You could call this whisper, like a function, and it takes the shader. And I never remember the function syntax, so I hope this is right. It is, wow. And so when we initialize it, one of the things that we can do is we can initialize the V table. And what you'll typically see is that most programs will have a static V table, right? So this V table will be initialized like as one object, and this becomes like a pointer, if that makes sense. And so it means that instead of having to like have like a bunch of these objects copied around, you save a lot of space, right? So you just kind of have like one V table that's located somewhere in memory, and that's just like repeated for every object. In this case, I won't do that just for simplicity. But I could do something like this, and this equals whisper. And I mean, this could be above it. I don't really know. Should care, but for some reason it isn't. And so this would be a very simple way of writing it. And in this reason, now we can now write arguably a not much better way, but we can still write it for class, right? We still have to give the shader object, right? So we're not really saving in a lot of space, but like you could write macros and stuff if you really want to go crazy, like vcore, right? Again, take a bunch of arguments, with a function, and you do something like this. Right? That's not actually necessary. Anyway, so we could do something like this, and then you could do all this, craziness around this and so on. So this becomes nice. Again, the other thing is, this is way too past the actual state of the course, so I don't care too much about it. There's no bugs, right? But these are functions that are going to be the same thing, right? Again, we've kind of just traded this for this, which we haven't saved much, but the point here is to show you what actually Java is going to be doing, right? And we'll be coming back to this probably in 3 weeks' time or 2 weeks' time when we look at inheritance and see how the structs can kind of balance each other and how we can kind of enable inheritance from a C perspective. I think it's useful to get some balance behind it. Otherwise, when you write inheritance, you can not always realize how it's actually working, and it can seem a bit magical, and also sometimes it can be really slow, and you don't know why, right? And the main reason why is because this function pointer could be anything, right? So it kind of creates that abstraction. And so the point of the abstraction is that you're having to craft some more boundaries in your code, right? So you're having to jump all over the place to find this function that you want to call, rather than just knowing it's right here. So particularly virtual cores are more expensive. Anyway, I think that's all. I think that was probably a bit less useful than I originally intended, but hopefully at least it sparks some interest going, oh, that's kind of cool. So we're going to go straight into the lab now. I typically like to keep in time, so I'm not too bad this week. I'm a bit behind. And in doing that, I will just once more kind of go over the course outline, kind of indicate the important parts for those that came late. The tutorials each week, as you kind of saw during the beginning, are going to be a bit more interactive. And then when we get to the code, I'll kind of be showing off some stuff and maybe doing a bit of interaction. But typically, interaction with code is really hard to do online because of the delay. It means typically it takes a while. But we'll see. And then we get into things like the laboratory class, which is what we're going to do now. You can demonstrate your code to us either this week, next week. I don't mind when. You can find the link. I mean, I guess I could just like post the link, to be honest. That probably works well. I don't mind too much. If you could share, that's good. But else, I'll just look at your code and For something like this, it's showing it's not that important, but I mean, I'm gonna get you to run the test script, but in future labs, it's more important when like the code's not so easy to verify. Honestly, just share your code, show me it, and that should be fine. There's a bunch of things here about adding your SSH key. Please do that, else you'll have a lot of pain later on. Yeah, there's not much to talk about. We'll talk about projects and assignments later on. The assignment is worth, no, the labs is worth a little bit less than last time. So the final exam is a bit more important. And I'll kind of give some hints for that a bit later once we actually get into it. There's not enough questions to really warrant breakout groups, but I will create a breakout group for those who want to be quiet, just in case, because I think otherwise it can be a bit noisy for people. And we'll create some private rooms as well, because I'm sure people want to talk about things. Yeah, the rest of this, there's not enough questions to really warrant it. You can pop into the questions chat if you want to like talk to other people or us about like the questions, or you can pop into a private chat, and we can kind of talk to you and you can share your code or whatever. Okay, and I'll let you switch the groups if you want. Okay, everyone popped around.